This is Darren Pulsipher, and welcome to Rise of the Stack Developer, where the convergence of DevOps, security, and cloud-native technologies are changing the way products are developed. In today's episode, we're going to talk about the history of configuration management, DevOps, and this new Stack Developer. Being my first episode, I wanted to talk a little bit about my history and how I see that coinciding with this new persona we're seeing in IT and development, which I call the Stack Developer. So let's go way back to the 1980s, where I started programming as a kid for fun, writing in QBasic, everything from an inventory system that I wrote to help for a fledgling concession stand business I was running, and helping my dad in his dental practice write some software for him, all the way to in 1985, when I got my first Unix box from a lady named Mimi Larson, who was a friend of my mom. She worked at AT&T Bell Labs, and they wanted someone to try out their latest and greatest Unix workstation. So I got to play around with that for about 6 months. They gave me a Unix manual and a machine to play around with. And I had a blast. I learned everything you could. Totally geeking out on the Unix operating system and had a blast. By the time I got into college, I decided to study computer science and electrical engineering. And at the time, I also got a job on campus as a Unix admin. And actually, before I even did Unix, they dropped me in on a VMS VAX cluster. So I was learning operating systems at the time, lots of different ones. And a little bit later on in my career, I actually worked on an IBM 360 box, switching tapes and running things in the middle of the night on the weekends. The things you do to get through college, to work your way through college. But that background in system administration, plus my background in computer science, where I focus primarily on user interface design with good X11 and Motif. I was a UI programmer with a sysadmin background. And my first job, I call it real job. That was after I graduated. But my first job after I graduated was with a company in Toronto called ISG Technologies, where we were doing medical imaging workstations for radiologists. And I helped design the user interface for some of the tools that are used even still today for radiological display stations. And because I was a sysadmin type and a programmer, I ended up doing the builds every night. I thought it was cool, right? Because I could do programming as well as the sysadmin stuff that I enjoyed doing. So I ended up writing the builds and becoming the guy in charge of configuration management, which was something new to me, but that ISG Technologies at the time were using. In fact, they were just in the process of going from SSES to the newer RCS. And that was my first real foray into configuration management, which was really kind of interesting. It broadened my horizons even more as far as, how to get teams to work together and check in code and a release process, build process, all that stuff. I really enjoyed. And lo and behold, I ended up being the configuration management grunt and the guy that watched the builds every night as it took a while to build and deploy our software onto machines. It was something that kind of kickstarted my career and would be with me the rest of my career as kind of a configuration management guru. After working at ISG Technologies and in the medical imaging industry for some time, I came across these brand new version control systems that were more distributed and concurrent, because the old systems only really worked well on one machine. So people would log in, they'd FTP their code over and check them into an RCS system, or there were several different techniques that we used. But then came these brand new tools that were client server based tools, these concurrent versioning systems like CVS, and the grandfather of all of the client server configuration management tools, ClearCase. And for you young bucks that have only heard of ClearCase in the mythos, it did exist. And for 10 years, I harvested that money tree of being a ClearCase administrator. I spoke at several conferences at the Rational Users Conference on ClearCase and how to administer it, optimizations, all those great things. And for a while, I rode that money train because it was not an easy system to use, but extremely powerful. I even wrote a book about it. You can check out my book on Amazon if you want some nostalgia. I don't know how useful it'd be today. Not as used very much anymore as it used to be. I still come across it every once in a while, so it's kind of interesting to see. So after ClearCase, we saw some great tools in ClearCase that did something called build avoidance. And the build and test systems that were there were really about increasing the amount of cycle or decreasing the amount of cycle time and increasing your productivity by doing build avoidance. So it would analyze the derived objects from a build, like your .o files for C and C++. And if the code hadn't changed for that .o file, I wouldn't rebuild it. And that saved a lot of time, right? So these great tools came out of ClearCase and that whole ClearCase ecosystem on maximizing build performance and test performance and all that. There's some great concepts that came out of that. Shortly after all these tools were becoming extremely popular, a new breed of configuration management tools and some build and test and release tools started coming out as well. And the first configuration management tool that was kind of revolutionary in this space was a decentralized and much more simplified tool like Git and Mercurial. And in fact, Git and Mercurial both came out around the same time, but Git most definitely won that battle. And that, again, changed the way all of a sudden that we thought about configuration management and the way the developers worked together. Other tools began to emerge, some that, almost every build team in large companies built their own continuous integration or build systems and reporting and all that. But then tools like the good old Hudson came out, also known as Jenkins today, came out, and continuous integration and continuous deployment became even more readily available through open source. And now configuration management became easier to do. Build and configuration deployments became kind of the main focus now for configuration managers. And this new breed or this new name came up called the DevOps engineer, because time wasn't spent nearly as much in building software and much more now in deploying software and testing software. So this DevOps engineer really was born out of that necessity. And it's really interesting because DevOps is really the developer and the IT operations guys really being married together, because IT started taking some of the load off of the development teams that in the past were doing some of their own configuration management and or build systems themselves. So this DevOps role really came into play, which is a really interesting space, something that back in the 90s, we didn't even have the concept of DevOps, but we were playing that role. And it was typically your software developers that had some kind of background in system administration. They knew about Unix and Linux, and they ended up being your de facto build meisters at night, right? They'd code during the day and watch builds at night. And for you guys that remember the good old days, I remember because I was the build meister and I had to monitor builds at night, they gave me an ISDN line directly into my house, which was pretty cool because then I could work from home on some days. And back in the time, I was in Silicon Valley, living about 70 miles away and making that horrible commute. So that gave me the ability to work from home a couple days a week, which was great at the time because it was such a horrible commute. So that's kind of where we got in the 2000s with this DevOps. The turn of the millennium is when DevOps really kind of blossomed. We saw some really new technologies around virtualization and configuration management working together. And really things became more and more complex. A lot more client or three-tiered architectures meant not just building one piece of software, but building multiple pieces of software. And now we needed to really increase the number of cycles that we were doing. In fact, most of our time in these DevOps worlds were spent optimizing build times. Because if we could get our build down to just overnight, that was great because all your developers could check in their code and then you could build it overnight. And what would happen next was all the developers could see what the problems were, the tests that failed, and code the next day. So you were optimizing your whole team. So getting it down to 8 hours was incredible. I remember in one project that we worked on, they asked us, our build was 28 hours long. That's how long it took to build the code. And when we first got there, they had one build machine that it was building it all on. And I had some smart people working for me at the time, a bunch of build meisters or DevOps engineers, the birth of DevOps. And we spent a lot of our time optimizing that build, and we got it in under 5 hours, which was really incredible. Today, with the processors that we have today and the speed of solid state drives, I'm sure that build would probably only take like 5 or 10 minutes now. But at the time, we spent a lot of time reducing build and test cycles. Today, these DevOps are really working on continuous build, test, and deployment now, where a lot of those things that we used to do somewhat manual are now automated, and they are moving so much faster than they did before. So that's kind of the state that we're in today, is a lot of organizations are doing these release cycles much faster. I'll do a build and release instead of weekly or monthly as it used to be. I'm doing continuous build and test all the time, where I'm releasing several hundred times a day at different parts of my application stack. So we're seeing a major shift. And now with the really adoption of container technology everywhere, we're seeing it even faster now. We're seeing even releasing only small parts of your whole system that you need to do through microservices. So this is where we're starting to see another emergence of a new type of role in the development arena, and that is someone I call a stack developer. There's another term out there that people use called the full stack developer. This is someone that can do or a web interface or user interface. They could do the middleware and the back end. But I'm not talking about a full stack developer. I'm talking about something called a stack developer. Now, this is kind of a new concept, but I'm seeing it emerging in several of the different companies that I work with and that I consult with. And that is, they have someone on their team that is starting to build reusable microservices and reusable microservice stacks. So a great example would be like a mean stack, where I've got Mongo, I've got Node.js, and I have other microservices maybe that I'm throwing in there as well, and the ability to configure, release, and test that in a reliable manner, so I can use that stack over and over and over again. Now these stacks, and there are several of them out there now, but the idea that we really want is we want these reusable stacks that are tailored to specific domains and or specific companies. And in these stacks, it would include the testing of these stacks in several different environments, from a local environment that's running maybe on a laptop, in a dev environment where I'm collaborating with other developers. It's build environment, if I have to build and release software, test, and then also in production environments. And a simple mean stack, for example, that's 5 different environments that may have 5 different configurations. But for a software developer, I just program on my laptop against a mean stack, and it automatically gets handled in production, where it's highly available, and backups are automatically being done. It's highly secure, depending on whatever the policies are. So this stack developer is developing these reusable stacks across all these different environments. Extremely important if you want to take advantage of these new microservice architectures that are out there. It's very beneficial to the developers because they no longer have to think about all those things that they normally don't, right? Like security or high availability, that if they just use that stack, that all those abilities show up for them. So this is why I'm doing this podcast, because I think we're right at the beginnings of this stack developer, and we're starting to see the rise of these new people that are out there. If you're saying, hey, Darren, this has been around a while already, then you're ahead of the curve, because I can tell you from working with several different organizations out there that this is not as widespread as most people would think, especially if you've already been doing it for a couple years or so. So I'm trying to bring awareness to the importance of the stack developer, and to kind of almost document how this is all happening, and seeing the emergence of it and how it is going to actually change the way that we see products developed in the future. So in this podcast, you're going to hear lots of things that are happening. I'll do conference reports. I'll do things that I'm seeing and talking to customers. And we'll even introduce some of the stacks that I'm seeing are really out there and making a difference today. And hope to interview some of the other fellow travelers that we have. Thanks for listening to Rise of the Stack Developer. If you enjoyed our podcast, go ahead and subscribe, give us 5 stars, and let other people know. If you want more information, like tutorials, videos, white papers, check out our website, riseofthestackdev.com. Until next time, go out and build a new world, one stack at a time. On our next episode will be a conference report on DockerCon.